Drone. So drone plays a vital role, and in our college, Dr. Tengli has initiated a lot of activities for this drone technology. And today there is an inauguration of this program, that is an innovative workshop on this drone technology today and tomorrow. And Dassault Systemes, they are helping us since about 7-8 years. We are Meenakshi, the wife of our founder, Justice K.S. Hegde. Justice K.S. Hegde is the father of our Lokayukta, Santosh Hegde. You may be knowing Santosh Hegde was a judge. Again, he was also judge of Supreme Court of India and Lokayukta of Government of Karnataka. His father was Justice K.S. Hegde. And they gave us autonomy in 2007, that is within 6 years of the inception of the college. They only wrote a letter to me that you are the youngest institute as on the record by the Government of India to get the autonomy. And since 2007, end of 2 years for PG. We are having 11 undergraduate branches, 5 MTech programs, MBA, MCA, and total intake for the college admission is 1,500 every year. And our students are working very well. Even there also one student has got a appointment in, he is working in NASA, who was involved in this satellite project in our college. Now he is working in NASA in USA.
And collaborative aerial robotics. This workshop provides a comprehensive understanding of swarm dynamics, hands-on drone programming, and the diverse applications of the swarm drone. The objective of these workshops are to explore the swarm dynamics for coordinations in disaster management, agriculture, urban planning, and environmental conservation. The outcomes of this workshop will be, by the end of the workshop, all the participants will be equipped to design, implement, and deploy swarm drones across various applications, fostering innovations in aerial robotics.
And training at DDPA India mentored ITEC Commonwealth Nation students on industry skills at UTL Technologies and managed technical teams in the US for major telecom projects. His tenure as DGM at Nokia India was distinguished by an LSA award and CEO appreciation for learning delivery function for global customers. Flight Lieutenant A.T. Kishore, an aeronautical engineer, managed Picora missile battalions and received commendations for his contributions.
Learned colleagues and industry leaders of Dassault and other bodies, Wing Commander Sir, and all the learned students. In fact, the topic that I talk is very simple one that you will see after the inaugural. It's on vertiports, so that tomorrow when somebody talks about a vertiport is being built, you should not have a confusion about what it is. So then there was a requirement to identify a machine, let's say last 15 minutes where it was. So in a sphere of, let's say, within a circle that you can draw around the spot, then you can go and do search for it if it is missing. So after that, it was made mandatory for every flying machine, including aircrafts, that the birds must report their location. So for if you travel across any road and take your car, you have fast track. So you can recognize the ID of your vehicle. And once it leaves, then it becomes small in its form factor. You will not know except for some moving vehicle. So the challenge that all of you have to work as a solution is, how can I remove
things that we do with academia. But today morning, Professor took us around, and I saw the wonderful work that all of you have all done. So I don't think there is any need for PPT. So congratulations for that, and I'm really happy to see this kind of innovative work being done in colleges. Again, Dassault Systems is a new product. The first thing that they would do is develop a prototype of it, and then test it in the market, and then probably create few more test products, and then it was an iterative cycle. Today with the advent of technology, especially from Dassault Systems, all this can be done in a virtual world. We call it as virtual twin technologies. You can design a product, you can simulate the surrounding factors and things like that within a simulation platform. You can actually develop a prototype within some of our technology today about drone technology, but any product you take, so there is a lot of data involved, right? And today we live in the data era. There is a lot of meaningful insights that you can develop.
His educational journey by graduating from Kendriya Vidyalaya DRDO, Bangalore, and then pursued a Bachelor of Engineering in Mechanical Engineering from Sri Bhagavan Mahavir Jain College. Subsequently, he obtained a master's degree in aerospace vehicle design with a specialization in aircraft design from Kansas University. Shri Anurag Joshi started as an associate project engineer at Drone Aerospace Systems, where he focused on the design and development of low-cost micro.
Respected dignitaries and professors and all the students here, welcome to a good session which is going to be following today for your swarm applications on drones. Just 12 years ago, I was somebody just sitting like you, listening to speeches like me on drones, on how and what it could do in the future. Now I'm on this side and you're on that side. So I would like to tell you there is still a lot of work still to be done. Drones, what they were about 12 years ago, was apparent, for you to put your energy and effort into building something. I come from the industry side. Our company works into building digital twins for the infrastructure, energy and mining space. When we use drones to capture data and we provide actionable intelligence with that data which we capture. We are really trying to help out in a lot of problems which are available on site. We are still just at the initial stages of solving these problems, even after working in this domain from past 5 years.
Nice's journey began in Delhi, where he received a College of Engineering in Mysore. Furthering his expertise, he obtained an M.Tech in Industrial Automation and Robotics from Manipal Institute of Technology. Nice's entrepreneurial spirit eventually brought him back to Mysore, where he co-founded Pancha Chakras, a company specializing in 3D printing and composites. Today, he serves as a co-founder and CTO of Pancha Chakras, leading innovation and shaping the future of this exciting field. We welcome you, sir, and we request you to address
you all. And I extend my warm welcome to all the dignitaries and students, professors in the present here. Thank you. So, my interest in aviation began much earlier when I was in school, say 2006. Like Anurag sir said, I also started as an aero modeler, and my first experience at building a plane was a chuck glider. Ever since then, I was hooked into the awesome, world of aviation. And later on, while in end-to-end solutions for the defense and enterprise market of the country, but slowly we got humbled by the competition, and in the process we also learned that we are not experts in building a complete drone solution for any customer. So we harness whatever we learned and we are expert in, which is design.
Thank you for raising this occasion and inspiring with your addresses. Our gratitude extends to our principal, Dr. H.C. Nagaraj, for his encouragement and support for the event. Thank you very much, sir. Our gratitude extends to Dr. P.N. Tengli, Professor, and organizing committee of their meticulous planning and seamless execution of this event. Finally, a big thank you to all the attendees for this participation and engagement. Your presence and interest are what make events like those worthwhile. Once again, thank you.
Or also to some maths or something, it's simple subject. And today's newspaper has an update that New Delhi is the leader in metro stations. and Bangalore is next. Bangalore has 78 kilometers of metro with 45 stations. Metro and this topic of today has some logical relationship. So when you talk about UAVs, for children to play around, these are the ones they can spoil, it doesn't harm them. And these are small form factor ones. It's actually powered. I don't want to try to disturb our auditorium. Anyone is welcome to take a look at them soon after I finish my talk. So when it comes to the topic of vertiport, I will just do a delimiter of what are the UAVs. So that's like that. It's no more a science fiction because United States Postal Department keeps a number of these UAVs in a Volvo-like vehicle, and there will be a canopy which opens up, and depending on the street, it comes to near to the street, it won't take turns inside lanes. It will be on the main street. The corresponding UAV which is loaded with the packet meant for a family goes, takes off, delivers, comes back and lands back there. And there is an analogy to birds. By the way, every UAV is addressed as a bird in technology parlance. A bird, it may fly off and then it may perch. One simple word you remember, P-E-R-C-H. Like with its grip of its fingers, it has 2 feet, right, and the hands like that, grips to the branch of a tree, that is perching. Education is going on, everything is free, so that has got a place where this kind of vertiport can come up. Wherever, like on the ISKCON temple, if they have a space, they can have a smaller version of a vertiport because of the height they enjoy. Safety standards. Normal aircrafts have a lot of things in their defense to defend why we need a pilot in the aircraft, because they can land people safely. There was an example of, there is a movie all of you, I suggest you to watch in Netflix today in the evening. Sully, one pilot handling passengers from old airport to the new one, for instance, from HL airport to international airport. You can take them in a vertiport, in a UAV, provided there is a vertiport in the old airport area, and then of course new airport area 12 kilometers beyond, and there can be a monorail or a metro train connecting from there to take you to airport again. And overall total cost of ownership and public-private partnership model, pricing, usage, more usage, price will come down. And so total cost of ownership is like, who is going to invest? Is it Adani, Ambani's, or who are they? Like, smart cities. I studied about 500 smart cities in the world. Unfortunately, the result of my research is submitted to United States one academic unit, is that it's a negative result. They haven't done good job. One smart city, Bengaluru alone, 1920 crores they spent. What smartness they have delivered to us, except one LED screen which will tell you the particles that are there in the air, and people who are, the number of people generally exponential. Its growth is, they just give some stats, really doesn't relate to your improving health or something.
So all these days work was being done completely manually, right? So if you have do inspection or a survey of any particular area or any particular segment, you would have a person, take a small station, you would see them on the roads, on some sort of sites. They would be standing in one particular corner, trying to do a survey by taking points. The issue with manual work is there's a lot of error which creeps into the data which you generate. Right? So the reason new technology is being built is to completely automate some features. You basically, these are the reports, these are type of reports which we generate. Drone flies, it captures hundreds and thousands of images which basically are processed or stitched together, which basically is as good as measuring or doing a site measurement with you on a digital platform. So it's like having a 3 to 5 centimeter of accuracy on a land. Basically, this land has become an island because of the dam which they have opened up because of the water flow. There are people stuck who require medicines and food supplies for almost 15 days. So this was an immediate requirement which with a single drone we were able to achieve. But imagine swarms being in play and then doing this work for multiple locations where they require this sort of help and support, which basically makes it very useful tool. So these are different segments which you can look at using swarm for providing assessment and providing the utilization to the end customer. So I'll close at this. If there are any questions, I'd like to take it and I'll move forward.
I'm in the Aero department and mainly to my friend and classmate Dr. Stanley, who's spearheading the R&D activity in Nitte. I'm not well prepared for the talk since he requested me to say a few words. I would like to share my experience in Air Force and DRDO, and I was successfully, it's still flying, Rustum is flying, robotics for applications. Then we have Rustum 2, it's known as Tapas Beyond Visual Range. So this is supposed to be a male UAV, medium altitude long endurance UAV, with a flying range of 1000 kilometers and an endurance of 24 hours. To some extent, the technology demonstrator proved its mettle, and hopefully DRDO will go ahead with more UAVs in this HALE configuration, like the one in the Global Hawk, where it can fly across continents and do the missions and come back. So with this little sharing of information, now I am into trying to motivate youngsters like you to join defense forces, mainly through CDS and NDA as officers in Indian Air Force and pilots in Indian Air Force and Navy and Army. So I will come to that a bit later with the help of Dr. Stanley, and I will tell you what are the openings available in defense forces as an officer and what are the advantages of being in defense, civil defense. So generally you find that in you do engineering and do some courses, then get onto some IT company, and many times you are put on the bench where you are glued to the laptop, you are a night owl. I would, sorry for use slang, but generally you are glued, even you are living in the virtual world. But whereas in defense, you are in the field, you are facing real challenges, and the starting salary for any cadet joining NDA or in defense academy is 56,000 rupees, which is much higher than what you get in IT field as a startup. As a starting point, you may get maximum 25,000 rupees unless you are brilliant and you get MNCs, whereas you end up putting 10,000 rupees on the bench and waiting for the position to come. Here you are in the real world, every day is a new challenge for you. And I will talk about a bit later. So I wish all the best for Swarm Drone Workshop, and hope end of the day you will be able to take home some actionable intelligence information where it will help you with your future life as an engineer and entrepreneur. Thank you so much.
We also have with us Captain Abhilash, Career Counselor and Trainee. We request you to share a few words.
Hi, good afternoon everyone. Initially I would like to thank for all the presenters from Nitte who invited me and Dr. Kishore. Currently myself is Abhilash. Okay, I have been in aviation industry from past 2013. I have completed my Bachelor of Engineering in Aeronautical.
So accessories. Accessories is a very loose term that I am using. You can say drone parts. And the transition from military to civilian drone has been an important milestone in the journey. and this has laid the foundation for all the indigenous drone companies and technologies that are being developed presently. Some of these key milestones: drones evolved from a basic remote controlled toy to a very sophisticated drone. What you see here in the picture is a DJI Mini that is used mainly for photography and entertainment purposes. Then indigenous drone manufacturing also came into picture. This gave rise to drone regulations by DGCA, and later on the indigenous drone companies started implementing AI tools on their drones, like how Mr. Anurag told that they are working on making digital twins that is achieved by AI, and your own very aero team of this college, they are implementing AI for their own swarm drone technology. As Professor Prahalad introduced me to this team, and they you can discuss with me, not just among yourselves. Amphibious drones. So these are some of the potential solutions. Already some of these have been discussed in the previous sessions, like e-commerce and package delivery, like Sir said, it is being carried out and tested in the America. In agriculture, for precision farming using AI tools and crop monitoring. It is
of 2 drones. That is what we are aiming for, and all of you would be getting the basics of the drone, the subsystems, electronics, propulsion, flight computer, as well as the image transmission, radio transmission, all the other subsystems of a drone. So what you're seeing right now, can anybody guess what this is? Who is the fastest runner here? Who can run very fast? Anybody? So I know everything here. Okay, no eyes, no eyes. So what we're trying to do here is, so what you're seeing there is, that's a Z camera, okay? So that's a stereo camera. So your normal cameras, if you take a picture, how will you get a depth perception? So how can you see an object in a 3 dimensions? So you need 2 cameras for that. That is why your phones have 2, 3 cameras to get the another perspective. That is your depth perception. So for example, if you close one eye, you will lose your depth perception. Right? So try doing this. Okay, close one eye and try to touch your 2 index fingers like this. Only like from a far distance, try to get it. You will lose that depth. Try. It's not perfect all the time. Subsystems need to work on a very stable platform. So what is my most stable platform? It's a 450. I put in all my subsystems there and I check if my subsystem is working. If it is working, I try to move to a better frame. That is what we have exactly done. So we have worked with our 450, 550 mm frame. Then we have built our own edge frame, which is in the lab, I'll take you guys there after this workshop. So, entirely similar to your flight computer. Okay. Without a physical flight computer, you can actually simulate a drone here using MapRoxy. So MapRoxy has all the modules which are there in the flight computer. So basically, when I run the MapRoxy with my commands, so the MapRoxy exactly simulates how a flight computer should behave. So that that is exactly what we have done. So initially to start out with four within them and then to do my simulation. So that is what we have done, a swarm of 5 rows. So this is your simulator. It's called Gazebo. It's a real life simulator. Yeah. So real life physics simulator. So you can give a firmware. Correct. So I have a firmware. You have 2 firmwares in your autopilot. One is your autopilot. Other one is your PX4. Okay. So this is my flight computer. The orange. This is the most advanced flight computer that there is in the market. This is called Orange Q Plus. Okay, this has 2 IMUs and a lot of redundant sensors. So when I say sensors, it has a redundant accelerometer, redundant gyroscope, and it has something called as RTK based, capability. So I'll tell you what RTK is when I come to GPS. So my autopilot is there. So this is exactly what we have. This is the system what we have. This is the RTK based GPS. This is the RTK based GPS. We have our onboard computer, we have our flight computer, and we have our telemetry, and we have our IM. This is the very recent trial where we were able to do a swarm of crew perfectly. This was a perfect synchronized flight. So as you can see, both the drones are in sync. Both of them take off together and land together. This was the recent trial. Tomorrow we are again doing mini shot, single shot, multi-shot protocols. Okay. So basically what does this do? Control the speed of a motor. Right? How does it control it? Using something called as PWM. PWM, pulse width modulation. It's basically what you're trying to do is with PWM. You're trying to turn on and off very fast. Okay? So what basically using the pulse curve, it's how much you're